Abstract. Smart contract platforms and cryptocurrencies have captured mass attention but still have not been able to achieve mass adoption due to scalability and user experience issues. Even on Ethereum, which is the most widely used smart contracts platform, there have not been many examples of dApps which have seen mass adoption. There have been a few cases where one or the other particular application temporarily succeeded in achieving a significant user base, but it led to crippling of the entire network during the high network load times. Essentially, this means that even the most advanced and widely used platforms are not ready for mass adoption yet. On the other hand, there are a few smart contract platforms which boast of higher transaction throughput, but they compromise on decentralization in order to improve transaction speeds. Also, many of the upcoming solutions propose developing their own blockchains, neglecting the billions of dollars of market cap that dApps and other projects have already created on platforms like Ethereum and others. More importantly, they neglect the massive developer community and developer ecosystem that currently exists on platforms like Ethereum. Matic Network strives to solve the scalability and usability issues, while not compromising on decentralization and leveraging the existing developer community and ecosystem. It is an off/sidechain scaling solution for existing platforms to provide scalability and superior user experience to dApps, user functionalities. The Matic development team has chosen Ethereum as the first platform to showcase its scalability and already has a working implementation for Ethereum on Kovan testnet. It is expected to allow near-instant transfers, exchange and conversion of digital assets, for example crypto tokens, and cryptocurrencies in the future. The Matic network is an adapted implementation of the Plasma framework for Ethereum to start with, but the vision of the Matic development team is to provide off-sidechain scaling solutions for blockchains in general. Matic Foundation intends to provide Matic Wallet, payment APIs and SDKs, products, identity solutions and other enabling solutions that will allow developers to design, implement and migrate dApps built on base platforms like Ethereum. One of the key pillars that form the basis of Matic Network's ideology is the improvement of user experience. This area is poorly developed for blockchain applications as of now. The Matic development team has already built high-quality user experience mobile, web browser libraries, which will enable businesses to create real-world end-user applications on a large scale. The development roadmap of the Matic network also includes supporting cross-chain transfers and third-party decentralized exchanges, liquidity pools, etc. Why Matic? Decentralized dApps are being proposed in large numbers, but the current blockchain ecosystem is not prepared to scale to match the demands of end-user applications with mass adoption. Moreover, the user experience of dApps is very poor and in no way conducive for average users. Slow block confirmations, high transaction fees, low scalability and poor user experience are some of the key roadblocks for the mass adoption of blockchain applications. The following section explains the problems prevailing in the current blockchain ecosystem and how the Matic network intends to solve them. Detailed technical specifications are provided in the further sections of the white paper. Slow transactions. Blockchain transactions are typically very slow and have a very limited throughput. Most proof of work based blockchain protocols have a limit on the block's size and it takes a certain amount of time to generate a block. Each transaction also has to wait for multiple block confirmations due to potential chain reorganizations. Proof of stake based blockchains try to counter these limitations using a staking mechanism, but the blockchains that are able to achieve high throughput with POS are able to do so at the cost of decentralization. These limitations are often a necessary condition for public blockchains to ensure security and decentralization, where a block needs to be propagated through the network and validated by all the nodes to achieve finality. The Matic network solves this problem by using a high-throughput blockchain with consensus provided by a selected set of block producers, chosen for every checkpoint by a set of stakers. It then uses a proof of stake layer to validate the blocks and publish periodic proofs, Merkle routes, of the blocks produced by the block producers to the Ethereum main chain. This helps in achieving high level of decentralization while maintaining an extremely fast, less than 2 seconds, block confirmation times. Low transaction throughput. Public blockchains have to maintain a certain amount of time lag between the production of adjacent blocks so as to ensure ample time for block propagation. Also, the block size needs to be small so as to ensure quick propagation of the block through the network. This entails that the number of transactions in a particular block need to be fairly limited. The Matic network solves this problem by using a block producer layer to produce the blocks. Block producers enable the system to produce blocks at a very fast rate. The system ensures decentralization using POS checkpoints which are pushed to the main chain. Ethereum serves as the main chain for a start. This enables the Matic network to theoretically achieve up to 216 transactions per second on a single side chain. Scalability. As discussed in the previous section, the Matic network easily achieves a theoretical speed of up to 216 transactions per second on a single side chain. In future, the Matic network is expected to be able to easily add more side chains horizontally to increase the total number of transactions on the Matic chain while using the same decentralized POS layer. Theoretically, the Matic network has the capacity for millions of transactions per second with the usage of multiple side chains. Also, the mechanism to do so has already been demonstrated with the first Matic proof of concept with the first Matic side chain, and new chains can be added in due course of time. Size of blockchain. Each block on the blockchain and/or compute state in case of a smart contract-based blockchain must be validated by multiple nodes. Each node has to manage a copy of the state and the blocks. While the chain increases in size as the days go by, maintaining and validating the whole blockchain becomes difficult and results in fewer full nodes in public blockchains, which poses a risk for decentralization. For the Matic network, the primary layer which provides decentralization may choose to store only the blocks of Matic chain from the previous checkpoint to the next checkpoint. All previous transaction block proofs have been submitted to the main chain. This enables extremely low-fidelity POS nodes which can be run in very low-cost machines with low storage. In future, the Matic network intends to enable mobile device-based POS miners too. Multiple micropayment channels with other off-chain solutions. Some payment channel solutions have proposed solutions to solve the problem of micropayments. However, the process of opening and managing channels with multiple dApps or users is complex. Additionally, the speed and convenience of mediated payments over channels is still up for debate. Since the Matic network uses a state-based architecture on an EVM, Ethereum virtual machine, it does not require payment channels to be opened between two parties. In fact, any valid Ethereum address is a valid Matic address, and a receiver does not need to be on the Matic chain to receive payment. They would only need to have a Matic wallet when they want to retrieve the payments on the main chain or spend it in the ecosystem on the Matic network. High transaction fees. With the rapid growth of the blockchain ecosystem, new crypto assets are increasingly being created, transferred, and sold, often involving multiple crypto tokens. Also, most decentralized dApps have their own token and economy. Paying tokens for the services or doing any kind of transaction on blockchains requires on-chain transfers. Every blockchain has a transaction cost structure. For example, Ethereum charges gas fees on each transaction. The amount of fees is an important factor to incentivize validators and prevent certain kinds of security attacks such as DOS. However, there is the problem of variation of fees, depending upon the pending transaction pool, due to the limited block size. The Matic network enables low-cost transactions through achieving economies of scale by doing a large number of transactions on the block producer layer, which ensures low cost, and then subsequently batching the proofs of the Matic blocks using the Merkle route of the blocks to a highly decentralized main chain, for X. Ethereum, using a decentralized layer of POS stakers. Poor usability. User interactions on dApps are often poor compared to their centralized counterparts. For the decentralization revolution to achieve mass adoption, the user experience of dApps has to be on par with, if not better than, their centralized counterparts. The Matic development team is expected to work on various mobile and web browser integration tools and is pioneering protocols in this domain. It intends to build a ubiquitous mobile browser app, which will act as a secured interaction layer for blockchain interactions. The Matic development team will be publishing the designs and prototypes of these soon.